Hey guys, welcome back. So today we are kicking off one of the most powerful ideas in programming, that is object-oriented programming in Python. So whether you are completely new to the idea or just brushing up your concepts, you are in the right place. Let's turn that spaghetti into the structure and reusable awesomeness. Let's start with the foundation of OOPS. So before we start, let's create a file for OOPS. We'll say new, we'll say Python file. We'll name it as OOP fundamentals.py. Enter, a new file is created. So what we are going to talk about today is OOP. Let's say what is OOP. This will be the first one. The next we'll talk about classes and objects. Next we are going to talk about instance attribute. Then we'll see class attribute. Next we'll see instance method. We'll see class method, then we'll see static methods. So to start with, let's start what is an OOP. So imagine you are building a car. Okay, so we're talking about what is OOP. So let's say you are building a car. You would manually craft each and every part every time, right? So you would create a blueprint, then assemble the car using that. And that's exactly what OOP programming is doing. Object oriented programming is a way of structuring code by modeling real world things as object. Okay, so these objects bundle together two things. So one is the data and the second is the behavior. Okay, so data would be, when taking car as an example, the data would be the color, the brand, the speed of the car, and behavior will be what drive it has, what brakes it has, can it honk or not. Okay, so in object oriented programming, you define a class as the blueprint, then you create objects from that class. It is just like building as many cars as you want from a single design. So to simplify it, you have a code structure for which you will create an object and you'll call it as many times as you want. Now, how is it different from the procedural programming that we were doing so far? So, well, before object oriented programming, we had procedural programming. That's where you write the code step by step using functions and data stored separately. So, it's kind of like writing down instructions to build a car in one page and storing all the other parts in another. So, every time you want to build a car, you are going to flip back and forth. So, in OOPS, the data and the functions that you are working for is stored together inside a class and you can access them using the objects. Storing data and functions in a class and accessing it using the objects created for it. Now, what is the benefit? Benefit is your code becomes reusable. You have good modularity in your code. So when you say modularity, your code is neatly divided into chunks. So you can easily organize, test, and maintain your code. Okay. It's like you are segregating. If you take an example of car again, you are segregating. The code for engine is stored here. The code for wheels is stored here. The code for brakes are stored here. You just have to call each of those and use it. Okay. So any changes you want to do in your brakes, so you have to hit the brakes class and go change your code there, and it will be applicable to all of the classes that you have created, all of the objects that you have created for the class. Okay. Another concept is the DRY concept. What is DRY? Is don't repeat yourself. What this principle signifies is, if you are creating a code for say you have a car which is a Swift and you are writing code for Swift, say you are going to create 10 different car, you don't have to create your code 10 different times. You just have to create an object of it, use it, and you are done. We talked about this. Let's see what are classes. Okay, and how do you define them? Right? What are classes and how do you define them? So classes are, we talked about this, classes are like a blueprint. So what blueprint is? So the blueprint is a set of instructions where you can which you draft for certain products. Say if you are building a car, you have a blueprint for the car. So the blueprint will not make the car, it will just give you an instruction how to make a car, right? Similarly, a class in itself will not do anything. It will just have set of code or set of instructions that you need to have to build a car, right? So let's say we have a class car. So how do you define a class? You just have to say class. Your class should always start with a capital letter. Okay. You have a class car. What you are doing inside it, you are doing, for now I'm just doing nothing. I'm just using the pass keyword here. So this is one simple class. Okay. We are using the keyword class followed by the class name. Class car is the class name and class is the keyword. Now, how do you create an object of it? Creating object is simple. You just have to name a variable, say my car one. Okay, I'm creating my first car as, what is the variable? What is the class name? CAR. That's it, right? And what I'll do, I'll just check what is this car one, and let's run this one. This is car object at some memory location. Okay, and if you want to see what is this type, let's see what is the type of this. So it's of type class. All right. Now, whenever you are creating a class, the first thing that we are going to do in a class is add a init constructor. What is init constructor? Init constructor is a special method that runs automatically when you create the object of the car. Okay. So let's take an example on constructor. Let's say if we have the same car example. Okay, I'll comment this one and I'll reuse this code here. So we have the class car as defined here. Now I want a constructor inside it. So I'll say define init, and I don't want these many things. I just want, so if you see here, by default a self is created here, and then I want something called as brand, and I'll say color. Okay. Now here what we did, we created a constructor with two parameters, brand and color, and it says self.brand is brand, self.color is color. So what it will do, as soon as you are creating a car, you have to pass the brand and color of that car. It will automatically create an attribute for your car. But what is this self thing here? So self gives you a reference of the current object that is being created. So say you are creating car1 as car, right? So this is your car variable. Now this car will also have to, I mean, from here also, it will refer to the same instance of which is from where it is being called. Say I called the car here with, say my brand was BMW, and uh, my color was, say, white. Now what happens when you create this, when you call this class with these parameters, it will create an instance of it. Car1 is the current, is the object, right? So this object will use the self reference. So whenever you give a self here, it is referring to the current instance of the class. Now if you have to access the brand and color of the car, now what you are going to do is you are going to print car1 dot color, and similarly you're going to print car1 dot brand. So when you are accessing color, you are getting white as color, and when you are accessing brand, you are getting BMW as the brand, right? What if we don't pass this here? What if we don't have this self dot brand, or let's say we don't have these lines here, and I'll say pass. Okay, let's run this again. What happens? So it says the car has no attribute like color. Why? Because I am just passing two parameters from here, which is going to my class, but I'm not doing anything, right? So I need to set these parameters in my class saying whenever this object dot color is referred, so I need to pass the particular value that is passed while we were creating the object. Okay. So instead of pass, we are going to have self dot brand is the brand that I have passed, and self dot color is the color, right? So from here, when I'm creating car1 is equals to car, BMW and white, what I'm saying is what I'm saying here is you add the attributes to my class object. This is done using the constructor init. Okay. And when I'm trying to access it, I'll just say car1, the class, the object name dot whatever attribute I'm trying to access. I'm accessing color and I'm accessing brand. All right. Let's see what is instance attribute. So instance attribute are the unique details of each car that you create. Okay. This is nothing but how we had seen here. We had talked everything there. Let's take the same example because it's nothing different. Okay. So when you say instance attribute, what is an instance? An instance is an object of the class. Okay. So when you are defining car1 here as an object of your car class, so car1 is your instance. Okay. And the attribute that it has. So the attributes are nothing but, in plain simple language, we need to understand this. When we say instance attribute, we are referring to variables, and when we are referring to methods, we are referring to the functions which is inside class. So the functions inside class are referred as methods, and the variables that are inside your classes are referred as attributes. As simple as that. Now, what is your instance attribute? Your instance attribute is your this particular instance. Attribute is again variable. So whatever variable I'm trying to refer using this class object is my instance attribute. So here the self.brand and self.color is my instance attribute. Why? Because these attributes are being referred to this particular instance. Now, if I have another instance created, Now this time I'll say my car 2 is again BMW, but this is red in color. Now if I try to access these, or if I run this, what will I get? Okay, so let me change this also, car 2 and car 2. Let's run this. What am I getting? The first one is white and BMW. The second one is red BMW. Okay. So if you closely observe here, so every instance that I'm creating will have their own set of attributes which is defined inside the class. And how are we defining these attributes? We are defining it using an init constructor and using the self keyword inside my init. Alright, then moving on to class attribute. Okay, before we move on, what if we want to change the color now? So you need to modify the instance attribute. How would you do that? So modifying is also pretty simple. Now this time say instead of BMW, I'm going to change the instance. I'm going to change the attribute for car 2. Okay. So how do I do it? Simple. Let's whatever is the object instance, we'll say car 2 dot. We want to change what brand? We want to change the brand as, what do we want to change it to? Let's say we'll change it to Kia, and we'll print it again. So what happens here? The first time it will give me white, the second one will give me BMW, this one will give me red, this one will give me BMW, and I am again changing it to Kia. So the car 2 brand will again get changed to Kia. Alright, and I'll get Kia here. Let's run this. What am I getting? You see, you're getting Kia towards the last one. So this is how you change your attributes. Okay. Now let's imagine that every car that we are making comes out from a new motor company that I have. So I have, say we have a company called Psudo Motors. Okay. So every time I don't want to pass the manufacturer from here. Okay. So say the brand. So brand is Psudo Motors now. And all the cars that are going to come out will have a brand of Psudo Motors. Okay. Now I don't want this to be changed every time, right? So what I will do, instead of defining or passing it from here, I can define it directly inside my class. Okay. So let's comment this. Now to see the class attributes, what we are going to do is we are going to have a class. We'll say car, and we'll just define brand here as, we'll say Psudo Motors. Now this car anyways is having a single manufacturer that it is supposed to have, right? So every time when you are trying to access this object, how would you access it? You'll just have to create an object, right? And you'll have to pass this particular attribute name, right? And you can also use the class reference to access it also. All right, so there are two ways. One way is you are going to create car1 is equals to car, and you are going to say print car1 dot brand. Okay, the second way is you can directly print it using your class reference. So you can say car dot brand instead of car1. Car1 is your object, right? So you can also say car dot brand. So both of this should return me pseudo motors. All right, let's run this. You see, so the first one that we saw here was these attribute tagged to the class, or they were referring to the object instance. That's why we had used self keyword to assign values to the object references. The second one that you are seeing, this attribute is tagged to my class. So it doesn't have to have any object tagged to it. You can directly access it using the class name itself, or you can create an object and access it in the same way like we were doing it earlier. All right, so if you have to understand when to use a class attribute, okay, so let's say when to use a class attribute. This is used when the values are shared across all the object instance. For example, let's say an example considering car. So where will you use it? You'll use it where you have the company name, or say you have the version, or say you have a warranty period. So something which is going to be common for all the cars. Okay, so you can define it here. All right, so that's where you are going to use class attribute. Now moving on, let's talk about what are instance method. So instance methods are function defined inside a class, okay, which operates on the object's own data. Like we had seen instance attribute, we have similar thing called instance method, and this works with object's own data. So it will have your object reference tagged to it. Let's comment this. Let's see what instance methods are. So consider these instance method are some functions that your car can perform. Say a car you have can accelerate itself and it can apply brake to itself. So let's see how you are going to use instance method. So again, for instance method, you will have to have you'll have to have a class. You'll say car, and inside it you will have a init function. The first parameter init takes is self. The second parameter that I'm going to provide here is the brand, the color, and say speed, which I'll default to 0. First, we'll do the values assigning part. Okay, I'm assigning the object's value to the variables. This is done. My constructor is ready. Now, the next function that I want is to accelerate the car. So we'll say define accelerate. Okay, and we'll say self dot speed plus equals to amount. Okay, and my self will take amount as input. What is the speed amount that I'm trying to accelerate? And after this, I'm going to say print. We'll use an F string and we'll say self.brand accelerated with self.brand of color. This color accelerated with speed this much. Okay. Now, similarly, when you are applying brake, so we'll have define. We'll say brake, and we'll say self. And this time I don't want the amount. I'll just say when you apply brake, you have to come back to your 0th position or 0th value. Okay. So what I'll do is I'll say self.speed is equals to 0, and I'll say print self brand of color this gray. I don't want to display the speed because it is 0 now. So I'll say of color this has stopped. Now what I did, I created a constructor, assigned the values to the object. I created a method inside, and this method is doing what? It is accelerating. So whatever input I'm going to give, say I want to accelerate to a speed of 60. So this will take 60 and it will print me that the brand color and the current speed is 60. Now when I call break, it will say the brand color has stopped. Okay. So let's execute this, or let's see how we can call this. How we are going to call? We are going to call using the objects. So first thing we'll do is car1 is equals to, we'll say car, and we'll say what is my brand. I'm going to pass a value. We'll say Tesla, and we'll say blue. Okay. So we have Tesla and blue is the color. Now here if you see, I have defined speed as 0 here itself. So I don't have to pass a value here. It's not mandatory for me. I can pass a value, but for now I'm not going to, because I have set as a default value here. So when we write a value here, so it is my default value which will be assigned while the constructor is created. So I'll say car dot accelerate, and I'll accelerate it to 60. Okay. And then I'll say car dot brake. Let's run this. So what it will do, it will accelerate. It will first print me this message because I'm accelerating, and it will then print me the second one, the brake message. Let's run. So it says Tesla of color blue accelerated with speed 60. And when I'm calling the brake, it says Tesla of color blue has stopped. Okay. Similarly, you can create more object and use it. Now, these variables are not shared across different instances. Okay. So each instance will have its own value. But if you define something inside the class that we had seen in the earlier example where we were discussing about class attribute, those those variables or those attribute values will be shared across the class. All right. Moving on. Okay. So moving on. What if we want to do something that involves the whole class and not just a single car? Okay. So the answer is inside class methods. Okay. Let's say we want to track how many cars have been created so far. So to do that, we will use a class method. Okay. Let's see how we can do that. So let's create another class. I'll comment the previous example. Let's create another class. We'll say class car and say define unit underscore underscore. And check self. We'll take brand. We'll take color, and we'll assign it to my variables. So attribute is assigned here, and inside this car itself, I'll have another class attribute. We'll name it as car count is equals to 0. So each time my init function is running means each time I am initializing a new object or a new car is created, right? So every time this is happening, I'll say car dot car count. I'll increment it by 1. Now similarly, I need a class method which is going to print me the total number of cars. So I'll define it using define. We'll say total car is car count. Now we'll define total cars, and before this we need to use a decorator called @class method. So this will instruct my Python saying that this particular method is referring to the class. Okay. So while you are creating this function, it no longer needs self. Okay, it will use CLS. CLS is referring to your class instance. Now you want to print the number of cars created. So you will say print total number of cars is equals to cls dot car count. So I'm referring it to my class. Now to execute this again, we'll create objects and we'll create multiple objects this time. And then we'll check for the count. So let's create an object. We'll say car1 is equals to car. We'll say BMW and red. Car2 is equals to BMW and blue. Car3 is equals to BMW and yellow. And since we are trying to call the class method, we are going to use the class reference here. Okay. So we'll directly say car. We are not using the object reference, right? We are using the class name because we are trying to access the class methods. So remember this. When you are accessing class method, you cannot use the object reference. You have to use the class name and then the method that you are trying to access. Now let's run this. What do we get? So it says the total number of cars is 3. Why? Because we created 3 objects, right? So this particular method has a value which is shared across all the classes. All the methods and attributes inside your class. It is built up on the number of times the object was created for this class. Now, when do we use this? Use class methods. So when we use class methods, so it is used when you want to modify or access class level data. To modify or access class level data, or you don't want no specific objects. When you don't want any specific objects to be created, it just belongs to the class, right? Moving on, we have static methods. So what is a static method? A static method is a method inside a class, but it doesn't interact with the instance of the class itself, right? So it's basically just a regular function that lives inside the class, often because it logically belongs there, but there is no direct object references pointing to those static methods. Okay. And to define a static method, you have to again use a decorator, which is static method. So let's see how we can define a static method. So we have another class called car, or let's use the same example that we had seen earlier. So this is my class and I'm going to have a static method inside it. Let's say we want to check for license plate, okay, whether it is valid or not. So for that, we are just going to see if it has a 6-digit alphanumeric number or not assigned to it. We'll first say static method at the rate static method, and we'll say define has number. All right, we'll say, and we'll take the input as vehicle number. Okay, now this is define as number, and we'll say vehicle as. Now what I want to do here is I just want to check if it has 6-digit alphabet or not. 6-digit alphanumeric number plate or not. So what I'll write, I'll say return vehicle number is, we had seen this method, right, is alnum, and vehicle number, we'll say length of vehicle number is equals to 6, right? We'll say 6-digit number. Now to access this, we just have to pass it here, just print, and we'll say car dot has number, and we'll say a b c 1 2 3. Let's run this. So it says true. Why? Because we are just creating it as 6-digit and alphanumeric. Okay. So now if you see, we just have used a class reference and we have called the static method. Now if you consider the previous example that we had seen, what? We had seen the class reference being used here in my class method. So it has both static method and class method. Now both of them were called using the class name rather than the object reference. So how are these two different? Now if you closely observe, a class method uses CLS as its first argument here, whereas static method doesn't. It doesn't need any specific parameters. A class method can also access or modify the class state, while the static method can't access or modify it. So in general, if you see, a static method has no idea about the class state. Okay, they are just a utility type method which can take some parameters and work upon only those parameters. All right, whereas the class method must have a class as a parameter. Okay, so we have given CLS as the parameter, and for static method we haven't given anything. All right, now comes when do you use this function? When to use static functions. So it is used when you want to keep the method grouped inside the class. Okay, you want it grouped inside the class, and you don't need any self or CLS as a parameter. So no self or CLS is used. And it is also, you can also call it as, these are helper functions. Okay, these are helper functions and not tied to the object state. Okay, not tied to object or class state. All right, so that's all I wanted to talk in the fundamentals of OOP. So the next one we'll talk about the OOP principles. All right, then I'll see you in the next one. Thanks for joining, guys. Bye bye.